These examples that we've done really help explain a lot, not just about derivatives of form fields, but they help us make sense of grad and curl and div, these different types of derivatives for scalar and vector fields. Say, I seem to recall there being something important about those, something I was supposed to remember because it is still important. Remember that thing about curl of grad is 0 and div of curl is 0? Well, now, if we interpret these derivatives in terms of the analogies that we see to 0 form fields, 1 form fields, 2 form fields, 3 form fields, etc., then what we see is an encapsulation of all of those special rules into one beautiful overriding fact, namely that when you differentiate a form field twice, what you get is 0. Instead of having to remember curl of grad is 0 and div of curl is 0, all you have to do is remember that d squared is 0. That means if you take a derivative of a form field twice, it is nulled out. It automatically goes to 0. Now, is this complicated? Well, no, more precisely, it's complex. It's really a very, very beautiful encapsulation of these otherwise picky sorts of results. I like to remember that d squared is 0. Okay, let's summarize what we have seen in this long and complicated but crucial chapter for calculus. A 0 form field in 3D with standard Euclidean coordinates is just a scalar field. A 1 form field is built off of these basis 1 forms. It's something of the form f1 dx plus f2 dy plus f3 dz. Likewise, a 2 form field has 3 components: f1 dy wedge dz plus f2 dz wedge dx plus f3 dx wedge dy, and finally, a 3 form field looks like just some scalar field f in front of the basis volume form dx wedge dy wedge dz. We've seen how to interpret these form fields. We've seen how to wedge them together. We've seen how to make sense of derivatives. Thinking of 1 forms and 2 forms as being somewhat analogous to vector fields through the analogy of work 1 forms or flux 2 forms. Thinking of 0 form fields and 3 form fields as being something more like densities. We have a really nice relationship between these structures, these fields, and their derivatives.